It is our pleasure to have a very distinguished panel with us today to discuss more on this topic. First of all, I would like to introduce Dr. Malti Goyal. Dr. Malti Goyal is former advisor and emeritus scientist with the Ministry of Science and Technology, Government of India. She has contributed immensely in the promotion of environmentally sound and clean energy technology in industry under the purview of various socio-economic ministries. She has a PhD in physics from IIT Delhi and obtained her postgraduate diploma in solid state physics from IITD with a distinction. Her master's degree is in physics with first rank from BITS Pilani. She received the gold medal. She is author of numerous books on topics related to energy and environment, and her most recent book is on climate change and green chemistry of carbon sequestration, published by Springer Nature in 2021. Dr. Goyal has founded Climate Change Research Institute and is doing commendable work in spreading awareness and education about environment and climate change. She is Lifetime Achievement Awardee for Education Excellence in Climate Change Research. So warm welcome, Dr. Goyal, to the panel today.
Thank you. Thank you, Dr. Gitanjali.
Pleasure, ma'am, to welcome you. I've seen you several times on various platforms, and you've also joined several of our programs. And so it's so nice that you could stay.
I'm very happy to reconnect, but I was also treasurer at one time in EC, about 2012 or so. So this is nothing special. That is all. And I'm really thankful to the president of association, Mr. Kalpen Shuklaji, for taking this initiative. He's really doing commendable work for the association, which we used to feel quite distant earlier. Now it's not so much and so long. So before I come to the topic of today's, because I have the longest association with the IIT, I think more than anybody, most of you, it's more than that. So I think I will first, the topic which was given to me was stay smart, love green, and go clean. So I was been thinking about it for some time. So before that, let me share with you about the multiple roles which actually careers or occupations which I have had in since I passed out from IIT Delhi. And I did my PhD in 1973 in physics. So it is going to be 50 years very soon. And I was proud participant of the 1969 batch Golden Jubilee already held in 2019. So you can imagine what long association. And I thought I can share also some of my observations about the changes in the environment which have taken place. You see, when I was doing my PhD, after my PhD, I was postdoc here and also research associate. So at that time, I was working on polymers and composites. And polymers and composites were just emerging materials. And it was being tried to replace them. They could replace the metals if they have they can have compatible properties. So that was the effort which was going on. And I also did some work in that direction. I used to go to textile department though I was in physics, but go to textile for doing some measurements. Then we also used Industrial Design Center, which was just coming, IDDC it used to be. So Development, Design and Development Center, and get some things made for our work. So I was working on electrical and mechanical properties. It was thought that if they can replace metals, the precious resources will be saved. And not only that, the energy will be saved by their use because they are much lighter. So both the factors were there. And these are the key factors of climate change mitigation. We need to preserve resources and we need to save energy. So they were quite exciting work was being done. And I was working in electrical and mechanical properties in research, because you can see I was there for quite some time, even after my PhD. And I recall one of the visits of very senior American scientist who came to IIT. And when I told him, he said, in the world, very few people who are working on both electrical and mechanical. So I felt very elated. Sometimes when we send a publication in international journal, it get accepted within 7 days. So that kind of excitement was there. But then nothing is constant. And the point which I wanted to also make is now that after some years, we have seen while polymers, composites were very successful for many applications, we face the problem of ozone depletion in the environment, some polymers, and we also facing now ocean pollution due to plastic waste. So now there is a trend to ban their use in at least some applications. So that transition has taken place during, when we worked and when we are seeing the results. Then I joined Ministry of Science and Technology in 1982. I understood with the understanding that I will come back to research if I'm not liking the government job. This was my thinking at that time. You see, when we guide the freshers, really, I also feel that we really don't know what we want to do. Like I only knew that I have to do my doctorate at whatever cost, but I didn't know what I'm going to really do or what opportunity or what kind of thinking. So that is also very difficult. It comes with the experience that you should have done that, or if somebody guides you, or sometimes you have a passion. All the things are there. So anyway, in the DST, though I did not have any formal training for their type of work, but because of my having done research in number of fields like interdisciplinary physics, organic materials, polymers, and I had not much, I was at ease in identifying the research priorities when the projects came, and that gave me little strength for working, especially in thrust areas, physical sciences, atmospheric sciences, also sometimes taking technology forecasting studies. And the main thing was that when I was given the charge of intersectoral ministerial coordination, socioeconomic ministries, their goals were social and economic. So they were not very keen on R&D at that time. They're working now. So the thinking was that Indian technology is not as good. So let's better to import fertilizer. Others, they really mentioned that we don't want to go for it because, it doesn't work. So that kind of, and I could catalyze research in them because of my experience at IIT Delhi. And that was my success or achievement, you can say. Essentially, because of the working in the world-class institute like IIT, definitely gives you an edge. And this gives me, though I was in the public service and I could have some national level experiments conducted, national level projects successful. Maybe it is MST radar, which is a large scale laboratory now and near Tirupati, or it was a Mont Blanc's program, which was one of the monsoon experiment of India, first successful experiment, which gave data for the monsoon. Then or could be the zinc metal extraction or even helium gas extraction. Very topics. And that was to name a few. And this learning in IIT definitely guided me for that. So I'm thankful to my alma mater on that issue. And then in DST, after I left, superannuated from DST, having done whatever I could manage. And especially, gradually I also had association in the climate change program. Actually, I gave a climate change program for the Planning Commission that time now, which is in Niti Aayog. And then, so I had a wide exposure having that. And of course, there were many struggles initially because going from IIT to DST, there was a very much transition, which I think we can discuss some other time. So then the Indian National Academy invited me for being emeritus scientist. I joined there. And there my role was to set up a science policy cell because, abroad the academies are expected to advise the government on what decision to take on certain issues. And climate change was a hot issue. So I joined there, but then soon I got CSIR emeritus scientist also. So, and that I joined in JNU. So that was another excitement for me that I am working on JNU. I'm in JNU. I am a CSIR emeritus scientist because being from DST, you may not know that DST has about 35 institution, 30 institution at that time. And CSR, we all know that 40 R&D labs. So normally the in-house people will get that position of emeritus scientist and or academic professors from universities. So that way, I think I was fortunate to get CSR from DST, and that also was much excitement awaited for me. So that was how, and now after that, this is my urge to serve the society. I'm working in the Climate Change Research Institute. So that is what actually it helps me to give the learnings which I have shared with them. And we take the climate change education, take proactive actions, find science and technological solutions to these issues. And though there are social problems also, but mainly we have a focus on that. And we cater to vast canvas of like school students as well as teachers as well as researchers in academic institutions or industry professionals. Whatever we can. And during my own research interest continues in carbon capture and utilization. The carbon capture and utilization, maybe I'll talk a little bit later on, because that is what I thought I will focus on. So depending on that, during this period, we have brought out, after my superannuation, 5 books on carbon capture and utilization from prominent publishers. So this is the achievement. And then I have another book on which is on science diplomacy, which is another interdisciplinary area. You can see that also. So this book is also involves scientists as well as diplomats. So that is a very new topic for this part of the world, science diplomacy, and putting things together has been a big challenge. But I really have enjoyed working on this project because it was also one of my passion. So this is how it contributed to society in many ways. And the topic, like when I saw that stay smart, love green, and go clean. Now, stay smart, it relates to staying safe. For example, when you say stay safe, stay smart from COVID-19 or any such situations, smart solutions, for example, digital solutions for the buildings or digital marketing or even digital business. Smart cities, that all come to my mind when I see stay smart. So that's one thing. Then love green is forestation, plantation, reducing pollution by carbon sinks. This is another area. And go clean is the recycle, reuse, and reduce pollution or reduce emissions. So this is what I thought I will speak on go clean, because it is the for sustainability, it is one of the key topic for us. So let us look at this topic from the climate change point of view and from the Indian perspective as well. So climate change, of course, you all know that it is a key threat we have in this era, and we are facing it. We are even seeing the impact of climate change in our environment in terms of extreme events, frequent extreme events occurring. The cyclones, for example, in Indian borders have increased tremendously in last few years. And we also have a lot of other calamities, intense rainfall, which means we can see now the impact. Because I am saying why? Because in 1992, when it got officially known about this global warming, at that point of time, it was considered uncertainty, quite a bit of uncertainty. That is an intergovernmental panel on climate change, which actually discusses and decides the priorities for the whole globe, and then it gives the nations, there are climate change protocols. Now we have 2 protocols, Kyoto Protocol and Paris Agreement. So they are the guiding force. And in 92, their assessment used to be very uncertain, the things. may happen this way, but now we can see it is happening. So this is the change which has happened. So when I founded this institute, it was my passion, but I didn't know that it will become so much a reality very soon. And Earth is a dynamic system, so we really don't know about the future, but we know that.
If I can
hello.
If I can just interrupt you.
Yeah, please tell me.
Yeah, so ma'am, recently we had COP26 and Prime Minister Modi ji declared a 5-fold strategy. So we have highlighted very bold, ambitious targets. So what do you think about those targets, like non-fossil energy capacity to 500 gigawatts, 50% of energy requirements from renewable energy by 2030, total projected carbon emissions reduction by 1 billion tons from now onwards till 2030. So I would ask you that how are these very ambitious, are these bold, and are these a challenge for the world? So what are your thoughts, since you are an expert in climate change, and in the SDGs we have goal number 13, which clearly asks for
13.
Yes.
Yeah, but basically, though I was talking about energy, this thing, but you are very right. In fact, when I recall that 10 years ago, the solar cell prices, for example, I'm just talking about renewable energy first. Solar cell prices were so high that they were unaffordable. In 1950s, it was only used for space flights. Then it came down. In 1990s, we had various applications developed. And then in about 10 years ago, it was quite costly. Then the National Action Plan came on, which set a goal of 20 gigawatts of solar energy. And that time, I recall very well that there were a lot of discussions that we should have a midterm correction because 20 gigawatt is not at all feasible. Like we had only, at that time, we had only about 45 megawatt connectivity. So, it was, the deliberations were there. We should have midterm corrections for 20 gigawatt. Then came 2014 and 100 gigawatts. So from 20 to 100 gigawatts is a big jump, and within a few years. And we have seen already we have achieved about 45 gigawatts. I think, if I'm right, total renewable energy we have is about 96 gigawatts. So we have achieved, and we hope that we can move forward with a higher goal. And now 2030 is 500. I mean, out of 500, 300 is expected from the solar energy. So though it looks very ambitious, most ambitious program, India already has, and this is further ambitious program because this is a time when the world is talking about net zero. When you referred about COP, the discussion was net zero. Every country was asked to give their net zero target. And it was thought that they will decide that 2050 as net zero year for the globe. So every country was under pressure to give. And what is net zero actually? It's also highly complex. You all know that greenhouse gases give rise to global warming. So the net zero was, expected that whatever emissions which take place from various sources, including energy, industry, transport, etc. So they can really, we can have same amount of sink in the atmosphere, in the Earth system, so that there is a net zero balance. Like carbon cycle, we have a natural carbon cycle. It's nothing very new, but same concept. So that was the net zero concept, that the fossil fuel, which actually started with the Industrial Revolution, first Industrial Revolution, when steam engine came and mechanical power came in the human hands. Then before that, there was only human power or this animal power. So that gave us boost. And the countries who could afford, when the train came at the same time with the steam engine. Let me first begin with the mention of Dr. Saloni, Goel, when she talked about the plastic as also, I agree with her that even plastic management and plastic recycling does help in mitigating climate change. So that is important. But when we talk of net zero emissions, the idea is that one can reduce if we say that energy sector is contributing about say 60 to 70% of total emissions, though all the sectors are important. So if we take any action to reduce emissions, it is sustainability for all the sectors like energy, industry, agriculture, all the sectors come in picture, transportation. For example, hydrogen program, India has just announced on 75th anniversary of our Independence Day. And a green hydrogen program assumes that production as well as use is pollution free. How we reduce the emissions. For example, when we talk of renewable energy, as you said, big targets have been given. So that is because there is during operation of the renewable energy plant, because resource is whatever. When you convert, that's a different matter. But during operation, there is no emission. Or what other way you can do is to increase the efficiency of energy. So energy efficiency, both in production and use, reduce the emissions because the less amount of fuel is used for the same amount of output. So energy efficiency is the second one. And the third is carbon capture and utilization. So that is another thing that was envisaged, to capture carbon dioxide from the atmosphere and store it away from the atmosphere. Now, what that means, it's quite a complex technology, looks very, very difficult, but it is, but none of the technologies are really simple. Because you see, if you find the technology which were developed in 20th century are all becoming, can you hear me? Is it okay? Or is there break?
No, please continue. We can hear you. Yes.
Okay. So the technologies of 20th century are all becoming unsustainable. So we are looking for the solution in 21st century for technology which can become sustainable. So we can be sustainable. So that is one thing, and we need innovation for that. That we all agree. I mean, that is what we are doing. I mean, what Saloni told, or what Dr. Anil said, that we have to find innovation to apply those technologies which were already there, but we need to find another technology solutions. And as he rightly said, in the corporate sector, they have to adopt science-based solutions. Unless the COPs are taking attention to this, that industry must adopt science-based solutions for mitigating the emissions. So the third aspect, carbon capture, is from the atmosphere. Like it was thought that point sources, where about 8,000 point sources in the world, that is power plant, heavy industry, which are energy consuming. There we know that if we take such sources, they are so impure. I mean, they have so much of impurity that ultimately the gas separation is takes a lot of effort in energy. And now the direct capture of CO2 is now also being tested, and the forms of CO2 capture are being put at various places to capture. You can put, say for example, in your window, you can put a CO2 absorber and you can capture. So earlier it was thought that air which is having 400 molecules in one, having in 1 million molecules, only 400 molecules of CO2 will be very difficult and costly. And from the point sources where it is 12% of the flue gas, it may be cheaper, but it's really, it is different. But even CO2 capture at 12% is also very expensive, because you have to remove so many impurities in the process. So those impurities consume energy. So, and then if you utilize that CO2, again, it consumes energy. So if you use renewable energy for utilization, then it becomes as energy to energy. So that kind of approach is continuously being worked in a very big way. And that is why industries have to adopt such solutions, where at least energy intensive industries have been, so that COPs are now forcing them to adopt science-based. And what science is? Science is that radiation-based. It is a radiation phenomena that the radiation which is being absorbed by the gases, which is emitted from the earth, actually increases the temperature of the earth. It is, I mean, when we talk of climate science. So though we talk of observations of the past of CO2 has not changed for 800,000 million years, it was only 200, 300. Now it is increasing. It has become 410 in 2019, and it is expected to increase to more, 1 ppmv per year or so. So that kind of thinking, projections are made, and then how much it is impacting the earth. The earth will become much warmer than 3 degrees to 5 degrees, and 2 degrees is the limit. Limit for increasing heat is 2 degrees. So that kind of analysis, climate science modeling, and all that studies are being done. So I think we have to, and as you said rightly, that solar is getting prominence in the International Solar Alliance and this in the National Hydrogen Program. Both are the initiatives which will keep India at par. So we hope that things, the commitments of COP26 of India will be met if we keep our targets high. And if the targets are high, then achievements will be higher, definitely. So though it looks there will be problems, because none of the sources is really actually free from pollution. If you make a solar cell, or if you make, as Dr. Anil was saying, making a solar cell itself consumes energy. So that is there, of course. But then we have to adopt all energy solutions to be sustainable. And that will give access to rural areas, energy equity, as well as the sustainability. And if energy we see sustainable development goal, energy we see SDG 7, it has linkages with so many SDGs. So energy is the key factor which we have to look. So it connects with the poverty, it connects with the gender empowerment, it connects with the education. So we need to